name is John Cronk, Applications Director with XR Corporation. And today we're going to talk a little bit about using mixed capacitors on the outputs of switching regulators. In order to properly stabilize a switching regulator, you need to know where the poles and zeros of the output network are in order to set your compensation. Many customers want to use a mix of electrolytics or pos caps together with ceramic capacitors. In this example, we'll be looking at a 470 microfarad pos cap with about 18 milliohms of ESR. If you look in the catalog, that's a 4-volt capacitor. In parallel with that, we're going to put a 47 microfarad ceramic X5R, 6.3 volt. Here is a plot of impedance versus frequency. The two black lines represent the two capacitors independently. So this black line is the 470 microfarad capacitor, and this black line is the 47 microfarad capacitor. And each one independently will have its own ESR, and in this case we're ignoring inductance. At higher frequencies you'd actually see this coming up because of inductance. If you combine the two capacitors, what you'll do is here you'll add a little bit of extra capacitance. So you'll have 470 plus 47 microfarads, and so the impedance will be slightly lower. However, the ESR 0 still happens controlled by the 470 microfarad capacitor. So the impedance drops at this point, you have a 0, you come across, and now you reach the intercept of that ESR 0 with the other capacitor. You end up having a pole at this frequency. Now the 47 microfarad capacitor dominates. The impedance continues to drop until you hit the ESR 0 of the 47 microfarad capacitor. Now with designing with capacitors, mixed capacitors, ideally the crossover frequency of the switching regulator will happen sometime in this space so that this pole and 0 can effectively be ignored. So next series we'll take a look at how to apply this using XR's Digital Power Studio in conjunction with optimizing the performance of the control loop of this XRP 7704 family and XRP 7714 family. Thank you for your time.